Glass, it's in your windows, your phone, that beer bottle in your hand. But have you ever wondered how something so fragile starts as nothing more than sand? Today, we're going inside one of the most incredible manufacturing processes on Earth, where temperatures hotter than lava turn ordinary sand into the crystal clear material that shapes our modern world. The story goes back over 4,000 years. Ancient Mesopotamians stumbled onto something amazing when they heated sand with certain minerals and got a transparent solid. But it was the Romans around 50 BC who really cracked the code with glassblowing. Then in 1608, English glassmaker George Ravenscroft changed everything by adding lead oxide to the mix, creating what we now call crystal glass. Today, the global glass industry produces over 130 million tons every single year, worth more than $160 billion. From smartphone screens to skyscraper windows, this ancient craft became absolutely essential to modern life. Let's head inside a modern glass factory and see how sand becomes glass. It starts in the batch house where automated weighing systems measure each ingredient with precision down to 0.01% accuracy. The main ingredient is silica sand, about 70% of the recipe. Workers add 14% soda ash to drop the melting point, plus 10% limestone for stability. But here's the clever part. Most factories add up to 30% recycled glass to the batch. It melts at lower temperatures, cutting energy costs by 40%. Once precisely weighed, everything dumps into a specialized ribbon blender that ensures every particle is evenly distributed. Then it travels along sealed conveyor systems to the furnace. And this is where it gets intense. The furnace is an absolute beast, stretching over 120 feet long, 40 feet wide, and standing 3 stories tall. Inside, natural gas burners fire continuously at 2,800 degrees Fahrenheit, hot enough to melt steel. The flames switch sides every 20 minutes in what's called regenerative firing, where exhaust heat preheats incoming air, boosting efficiency up to 50%. Raw batch pours steadily in at 15 tons per hour. Over the next 16 to 24 hours, it slowly dissolves into molten glass. Workers monitor everything from a control room with over 50 thermocouples throughout the bath. Even a 10-degree deviation can ruin the entire batch. The molten glass gradually flows toward the conditioning zone, where temperature drops to exactly 2,400 degrees Fahrenheit, achieving perfect homogeneity. From here, different products take different paths. Let's follow flat glass first. For windows and car glass, the molten material feeds into a float bath, one of the most brilliant innovations of the 20th century. British engineer Sir Alistair Pilkington spent 7 years perfecting this process before its debut in 1959. And here's the genius behind it. Molten glass pours continuously onto a bath of molten tin, kept at exactly 1,050 degrees Fahrenheit. Glass naturally floats on tin because its density is only 2.5 grams per cubic centimeter, compared to tin's 7.3. As it spreads across the perfectly flat liquid metal surface, gravity and surface tension create glass with both surfaces perfectly smooth and parallel. The float bath stretches for nearly 200 feet. Modern lines control thickness by pulling at specific speeds. Pull faster, you get thinner glass down to 2 millimeters. Pull slower, you can create glass up to 25 millimeters thick. By the exit end, the glass is cooled to around 1,000 degrees and solidified enough to lift off without marking the surface. From the float bath, the ribbon enters the Annealing Lehr, a temperature-controlled tunnel over 500 feet long. If you let glass cool naturally, thermal gradients would create internal stresses, making it weak and prone to spontaneous breakage. Instead, the Lehr cools it gradually over 2 to 4 hours. At the exit, automated cutting systems use diamond-tipped wheels to score the ribbon into massive sheets, often 10 feet by 12 feet or larger. But bottles and jars follow a completely different process. This is where the IS machine comes in, standing for individual section machine. Invented in 1925, it's still the backbone of container glass production worldwide. Molten glass flows into a feeder bowl where rotating orifice rings cut the stream into precise portions called gobs. Each gob is sheared by pneumatic scissors with split-second timing, weights controlled to within 1 gram. A typical line has 10 or 12 individual sections, each making up to 4 containers simultaneously. Here's where it gets wild. In the blank mold, a metal plunger pushes down while compressed air at 40 psi blows up from below, forcing glass against the mold walls. This creates a parison, basically a thick-walled preform with the bottle's neck already shaped. Takes just 2 to 3 seconds. Then mechanical neck ring holders grip the parison, flip it upside down, and swing it to the blow mold in less than 1 second. Compressed air at 25 psi blasts through the neck, inflating it against the cooled mold walls. From molten gob to finished bottle in 8 to 12 seconds. A modern IS machine can produce up to 600 bottles per minute. Fresh bottles travel through an annealing layer for 30 to 45 minutes, cooling gradually. Then, every single bottle faces automated inspection. High-speed cameras check for cracks and defects. Infrared sensors detect stress patterns. Bottles must withstand at least 90 pounds per square inch internal pressure. Any failures get crushed and recycled back to the batch house. For specialty items like wine glasses, skilled craftsmen still use traditional glass blowing at glory holes, small openings into reheating furnaces. They gather molten glass on a blowpipe and shape it with hand tools. A master glassblower can create a wine glass in 5 to 7 minutes. Now let's talk about safety glass. Laminated safety glass in your car windshield starts with 2 sheets of float glass with a layer of polyvinyl butyryl plastic between them. The sandwich goes through rollers at 190 degrees, then enters an autoclave at 280 degrees and 175 psi for 90 minutes. This fuses everything permanently. The result? Glass that holds together when shattered. In an accident, broken pieces stick to the plastic instead of flying around the cabin. That's why windshields spiderweb instead of exploding. Tempered glass for side windows takes a different approach. Regular glass heats to 1200 degrees, then high-pressure air nozzles blast it from above and below. Surfaces cool rapidly while the interior stays hot, creating compression on surfaces and tension in the core. This makes it 4 to 5 times stronger than regular glass. When it breaks, it shatters into thousands of small cubes with dull edges instead of dangerous shards. Here's something mind-blowing. Gorilla Glass and other chemically strengthened glasses used in smartphones go through an ion exchange process. The glass is submerged in molten potassium salt at 750 degrees for 8 to 16 hours. Potassium ions migrate into the surface, replacing smaller sodium ions. Since potassium ions are 40% larger, they create a compression layer, making the glass incredibly scratch and impact resistant. Quality control combines automated systems with human expertise. For flat glass, laser scanners detect defects as small as 0.1 millimeters. Random samples undergo destructive testing. Chemical composition gets verified using X-ray fluorescence spectrometry. Everything must meet strict safety standards. The environmental impact has improved dramatically. Modern regenerative furnaces are 30 to 35% more energy efficient than those from the 1980s. And here's the crazy part. Glass is infinitely recyclable without quality loss. That beer bottle you recycle can become a new bottle, a window, or fiber insulation. Recycled glass melts at lower temperatures, reducing energy consumption by 40%. Some plants now run on 90 to 100% recycled glass. After manufacturing, flat glass often receives low-E coatings that reflect infrared heat while transmitting visible light, cutting heating and cooling costs by 30%. Container glass exits production lines at up to 1,000 bottles per minute, packed into boxes and stacked on pallets by robotic systems. the glass industry continues pushing boundaries. Researchers are developing ultra-thin flexible glass, less than 0.1 millimeters thick for foldable smartphones and rollable displays. New formulations create transparent materials strong enough for military applications while remaining optically clear. From ancient Mesopotamian workshops to cutting-edge research labs, glass has traveled an incredible journey. But at its core, the principle remains unchanged. Heat sand hot enough, add the right ingredients, and you create one of humanity's most versatile and enduring materials. So next time you look through a window, drink from a glass, or tap your phone screen, take a moment to appreciate the 4,000-year-old craft and modern precision engineering that made it possible. From sand to something extraordinary. Thanks for watching. Hit that like button and subscribe for more fascinating looks at how everyday things are made. See you next time.